Today's focus is going to be on lightning and electrostatics. All right, so let's talk about a little bit about electrostatic basically, which is talking about how electricity and static electricity is created. So the first thing you need to know is what is the charge of an electron, okay? Because it's really going to be these electrons are producing electricity, okay? The movement of these electrons conducts electricity. So what's the charge of an electron? It is negative. Okay, so if a particle were to lose an electron, what would its charge be? Well, typically a thing is neutral. So typically we have a thing, an atom, and it is neutral. And the reason why it is neutral is because you have an equal number of positives to negatives. Well, if I lose one of these negatives, okay, so let's say it goes away, what's the charge then? Well, then it would be positive, right? All right, so the next question. What will two like charges do? So if I had two, let's say, positives right next to each other or two negatives that are right next to each other, what would happen to them? Think of two magnets. If you have two magnets that are of like charges, what happens when you try to push them together? Do they go together or do they repel? Well, the like charges will repel. So what will opposite charges do? Think about that magnets and flip the sides. What happens to those guys? Well, they will attract to one another. Okay, so electrical forces between charges are strongest when they are far apart or close together. So go back to your magnets and think about if you put your magnets far apart from one another or put them close to one another. Which one would they feel each other's attractions more or repulsions more? Well, that would be when they are closest together. I use magnets a lot because you visually can see these things, but magnets are not electricity in the electromagnetic field or the electric field. So but they behave very similarly. So that's why I bring that up, and you can visually see magnets. All right, so how does lightning form? Well, static electricity forms from the lightning bolts, okay? And lightning is discharged from the static electricity from a huge cloud called a thundercloud. And also a single lightning bolt has enough power to light 100 million light bulbs. Okay, so what happens is basically what this says is that you have this cloud. Okay, so we've got this cloud. And within this cloud, the water molecules are moving up, they're moving down, whatever. When they do that, what they actually end up doing is they believe, this is not proven, but this is what they believe, that it strips the electrons, and the electrons actually gravitate, as you can see, towards the bottom of that thundercloud, which means if you have a negative, because I've now lost those electrons, what's going to happen? Well, where the electrons were lost, I'm going to have a positive. So now if you notice, I've got a positive end here, and I have a negative end here. Okay? So that's how it basically happens within the cloud itself. You get a positive end and a negative end within a cloud. All right, so we've got this negative end that tends to stand on the bottom. And I'm going to color these. Actually, I'm going to color anything negative. I'm going to color orange, or like this yellow color. Okay, so we've got the negative ends on the thunderclouds, and that's there. And then we've got this positive end on the positive because we ripped off those electrons by the movement of the water molecules. And so we've got a positive end to our cloud and a negative end to our cloud. Well, what's going to happen is that the positive ends on things that are neutral are going to be attracted to these guys in the negative end of the cloud. Okay, so now we have a positive ends, and we have negative ends. And so what's going to happen is that these electrons in this negative end are going to be attracted, as we learned during the electrostatic slide, they are going to be attracted to this positive end. And what's going to happen is it's going to move all of these electrons to this positive end, and it's going to go down to where this positive end is. Okay, and so then you become neutral. So when you do this electrostatic discharge, what's happening is that all the electrons are moving to a positive end, which means that they are making them neutral. Okay, so you're basically neutralizing it through 100 million light bulb volts. Right? Okay, so this is just another visual. So I'm going to do the positive ends. I'm going to color it blue this time. So we've got our positive ends. Okay, this movement of these electrons causes there to be a negative end. Okay, negative ends form on the bottom of the thunder clouds. And then what happens is that we've got this negative that will be attracted to the positive, and you will see a discharge go. Okay, but you also see that there's a positive end here and a negative end here, which means that these will also be attracted. So that's why you see cloud to cloud lightning also occur. You see ground to ground, but you also see cloud to cloud. All right, so there are a few different types of lightning that you are going to have to identify. One, and they're very, very easy. One is cloud to ground lightning. So what I want you to do is find where a cloud to ground lightning would be. There is intra-cloud lightning. Intra means within, so it's within the same cloud. And then there's cloud to cloud lightning, which is where you have lightning between one cloud and another cloud. The key to this is that you always want to find them where it is a negative going to a positive. That will always be where they are attracted to. You will never have a positive attracted to another positive. So we would never see this form a lightning right here where a positive is next to a positive. Okay, so let's do the cloud to ground lightning in this orange. So we need to find a cloud and where the lightning is then going to the ground. So you're talking here, you're talking here, you are also talking this guy right here, obviously, and then this guy right here. Okay, there are no positives really written. I guess it's over here, but this one's not as obvious. Okay, then let's do intracloud. I'm going to do that in purple. So intracloud is within the same cloud. So we see lightning right here on the left cloud, and so this is a negative, this is your positive, so this is where your lightning occurs. You also have this negative to this positive that would also find intracloud lightning. Okay, and then the last one we will do in green, and that is cloud to cloud. So that is from one cloud to another cloud. So once again, you want to find your positives to your negatives. So here is a positive to a negative. Here is a positive to a negative. Now my question to you is, what would this guy be if I were doing this guy on the right-hand side? What type of lightning would that do? Would it be cloud to ground, intracloud, or cloud to cloud? Hopefully you guys all think it's intracloud because it's within this same cloud that the lightning would be occurring. So that would be an intracloud. All right, hopefully you have an understanding of the basic process of why lightning occurs and the 3 different types of lightning that can occur.